So we're going to continue our discussion of prime factorization and particularly using Diviso or the rules of divisibility. So I gave you one rule which was, well, let's put the rules of divisibility numbers down for Diviso. So Diviso numbers are 2, 3, 5, and 10. Are there other rules of divisibility numbers? Yes, there are. We're concerned with these. We talked about the 2. We said any number that ends in an even number or 0, such as 20, 848, and let's say 56. 0, even number 8, even number 6. We can divide by 2. So we're doing prime factorization. We know we do something like this if worst came to worst. Are there other ways to break down these numbers? Yes. But we know at least initially when we start prime factorization, we can use 2 to start it off. Then we talked about the number 3. This one being a very powerful tool to use when it comes to rules of divisibility. We talked about numbers such as 111 and how normally you wouldn't be able to figure out what number you'd use. Some kids might even think that, well, there is no number. They might try 11 times 10 or 11 times 11, which wouldn't be true. But we know if we find the sum of those digits, which 1 plus 1 plus 1 equals 3, and if it can be divided, that sum, by 3 evenly, and of course it can in that situation, then we can divide this by 3. So we take this conjecture, which is sort of what hypothesis and mathematical talk. So we'll take our conjecture here, and we'll go 111 divided by 3. Let's see if we get a whole number if we divide 111 by 3. How many sets of 3 are there in 1? None. How many sets of 3 are there in 11? There are 3 sets. 3 times 3 times 3 gives us 9. And then I go ahead and take the value over there, then subtract, giving me 2. There are no sets of 3 that can go evenly into 2, so we bring down the 1. We found out that there are 7 sets of 3 that can go into 21. 7 times 3, 21. We find out that our conjecture, or our hypothesis, our conjecture here is true, that 111 does have some prime factors that make it up. They're 3 and 37. Quite a powerful tool using this one when it comes to some numbers like that. I want to provide 2 more examples for you here. Let's say you get a strange number like 39, and that looks like, well, there's no number you can really break that down by. Well, we find the sum of those 2 digits, that's 12. Can I evenly or divide 3 into 12 using an even number? Yes, it's 4. So knowing that, we go here 39, and I'll divide 3. Looks like I didn't have 3 sets of, I can have 1 set of 3 go into 3 evenly, and I have 3 sets of 3 go into 9 evenly, minus. And so we find out that 39 actually can be prime factorized to that. 3 and 13. Great little tool using 3 here. Let's talk about a random large number that you can still rip down quickly by using the rules of Diviso. So let's take 543. If we use the rules of divisibility so far and someone asks us to provide the prime factorization for it, we go there and remember our 4 numbers, 2, 3, 5, and 10. We talked about the 2, talked about the 3. The 5 or 10 are very simple ones, and we'll go over that once we get to them. So let's start from the 10. Well, we look at that. The rule is with 10, and most everyone knows, is that any number that ends in 0, you can divide evenly by 10. So we go over here. Let's look, does it end in 0? No, the number ends in 3. Cannot use 10 in this situation. Does not end in 0. Doesn't end in 0, can't use 10. All right, so we'll erase that. We'll go to our 5. Well, the rule there is that the number either ends in 0 or ends in 5. Now, you can look and see. It ends in a 3. Therefore, does not end in 0 or 5. Now, I'm not sure if you can really read this, but I'm hoping just me saying it as I'm writing it, you can rewind, go back and say, that's the rule. So we'll go over here, and then we'll look at, we have two more numbers. I'll look at the 3 here. So we'll go here. All right, let's add this up. So the sum of 5 and 4 is 9, and the sum of 9 and 3 is 12. We got a winner here. Looks like I can go ahead and start doing prime factorization on this using 3. That's my conjecture. So let's see if my conjecture is right. Remember, it came to 12. We're not going to divide it by 3. So let's see. So I'll take 3 here, 543. Let's go ahead and find the quotient. How many sets of 5 are found in, how many sets of 3 are found in 5? 1. 1 times 3, 3. The difference of 5 and 3, 2. There are no sets of 3 I can find in 2, so I bring down my 4 here. So how many sets of 3 are there in 24? There are 8 sets. 8 times 3 gives me 24. So I'm looking sharp so far. There's nothing left, or there's no sets of 3 that can go into nothing. So we're left with the last digit here, 3. How many sets of 3 are there in 3? There are 1 set. 1 times 3 equals 3. So it looks like 543, I've got 3 times 181. That number's prime. That one looks large. So let's see if it's prime. Let's once again review our numbers. 2, 3, 5, 10. I'll talk about 2, so this time I'll start here. Now this number, 181, doesn't end in an even number. Okay, ends in an odd number. The rule doesn't work. Let's find the sum of the 3 digits. 1 plus 8, 9. Well, we can divide that evenly by 3. But then I've got 9 plus 1. It gives me 10. I can't divide 10 evenly by 3. There's no even number I can multiply by 3 to give me 10. That doesn't work. Go here. And let's take a look. Well, does it end in a 5 or a 0? Nope. That doesn't work. And last but not least, does it end in a 0? No. Looks like this number is prime. So the prime factorization of 543 would be 3 times 181. And that's as far as we can go in this situation. I'm going to go ahead and stop this, then start up another video for you talking about other uses of Diviso.